Hello and welcome to Dotnet with CK, and our today's topic is Bitwise operators. So Bitwise operators, what are these Bitwise operators? Bitwise operators work on the binary bits of integer values. So for example int, unsigned, long, etc. Not on their decimal form. Think of them as operations on zeros and ones. So basically 0 and 1 are binary numbers. So we can think like the Bitwise operators operations are on binary numbers. Now first one is the bitwise AND operator. So let's look at what exactly this bitwise AND is. So here I have taken two variables, int a equal to 6 and int b equal to 3, and this is the decimal representation of this integer value. And here on the right hand side, this is the binary representation of this decimal number in 8-bit form. So here 6 is something like 000, 0110, and 3 is like 000, 0 and then 0011. So these are the 8-bit representation of these decimal numbers. Now you must be thinking like how it is converted from decimal to binary, right? So yeah, I will be discussing it in the next slide. So here you can see the int c is equal to a bitwise and b, right? And it becomes c is equal to 2. Now how it becomes c is equal to 2? So when you multiply this bit by bit from this 6 and 3, so 1 into 0 that becomes 0, 1 into 1 that becomes 1, and again 0 into 1 that becomes 0, right? So and then all we have the 0, so the result will be 0. That's why the the bitwise AND like a ampersand b becomes here, that is 40 and then 000, sorry 00 and 10, so that is the 2. And similarly we have the bitwise OR. So in case of this bitwise OR, what we have here, like we need to you can say when the same digits, or if it is the different digits, right? So it becomes that digit itself. For example, if we have, let's say, 0 and 1, so when we add it, or means you can just think like you can add it. So 1 plus 0 that becomes 1, 1 plus 1 that becomes 1 here, and 1 plus 0 that becomes 1 again, and again we have all the zeros here, the previous digits. So all these things will be 0. So here the a or b, that is the bitwise OR, a bitwise or b becomes here now 7. Okay, let's move to the next one, that is called bitwise XOR. And XOR is basically when the digits are different, then it becomes 1, otherwise 0. So here you can see a XOR b. Basically here you can see the first one is the different digit, so it becomes 1, and we have the same digit 1 1, so it becomes 0. And again we have the different digits, so it becomes 1, and then we have same digits 0 0, so it becomes 0. So here it is, like if it is same, then it will be 0, otherwise it will be 1. So this is the bitwise XOR thing. So again a XOR b becomes now 5 here. Let's move to the next one, and let's try to understand like bitwise NOT, that is the tilde sign here. So int a is equal to 5, and it works on the single digit basically. So here the binary representation of 5 is 40 and then 0101, that is the 8-bit representation. And here int c is equal to bitwise NOT a becomes now here the 2's complement, 2's complement, and that becomes 6. So here you can see like when we say bitwise NOT, it means you need to flip all the digits basically. So here when the digit is 1 it becomes 0, when the digit is 0 it becomes 1, and again 1 0 0 1, and then we have 4 0 4 1. And this first one, the first digit, basically it is signed, it tells about the sign digit, for example plus or minus. So if it is 1 then it becomes negative, and if it is 0 then it becomes positive. So that is what the meaning of the very first digit here. And let's look at the next thing. So for sign integer, C# use 2's complement. So bitwise not operator n is always n minus n plus 1. So here you can take an example like if it is tilde 0, then it is equal to minus 1. And if it is tilde 5, then it becomes minus 6. So this is the example or formula you can remember, like for any numbers, if you are trying to calculate the bitwise not, then it becomes basically that number plus 1 and then proceeding with a negative sign. Now let's look at the representation here also. So before that we can learn one more bitwise operator, that is the left shift. Now what is the left shift? So here you can see int a equal to 5, right? So here we have the binary representation of 5. So 101 basically the last one. So when you shift left, right? So basically each and every digits you need to shift left. So here you can see a shift left 1. It means all the digits should be shifted to left 1 place. So here the 1, if you shift this 1 to left, then here it will start from 0 and then 1, and then this 0 will come to the next place, this one will come to the next place. So here 101 becomes 1010 because you have shifted it to left. So in this way it works, and this becomes now 10. 1010 becomes decimal number 10. And similarly we have the shift 2. It means now you need to shift 2 digits left. For example here 01, so you can see the very right 00 and then 01. So this 01 comes to this place, and because you have shifted it 2 place left, and in the same way, so it becomes now 20. Now how the binary representation is there for a decimal number. So let's look at this one, like 1010, this is the 10. So how it becomes 10, right? So there are formula like the digit into 2 to the power number of digits after that digit. For example, here just take this one, because before that 0 it always be 0. So here you can take like 1, this first digit, this one digit, and then into 2 to the power 3. So after this one there are 3 digits, so that is the 2 to the power 3 plus this 0 again. So 0 into 2 to the power 2, 2 to the power 2 because there are 2 digits here, and then 1 into 2 to the power 1 because there is 1 last digit is 1, and again we have 0 into 2 to the power 0, so there is no digits here. So if you calculate all these things, so first one is 2 to the power 3 means 8, plus then again 0 plus here 2, so it becomes 10. So this is the you can say like binary representation of 10, right? And in the same way we have a binary representation of 20 also. So you can say 10100, and I have calculated it here. So this is the case. I hope you understood this left shift, and then also the how the calculation is done. Let's look at the right shift also. So it works in the same fashion, but it moves the digits right hand side. For example, here 20, 10100, and if you move it to the left, right shift 1, it means one digit it will go to the right, and if you move it to the uh, a shift a right shift 2, then it moves to the 2 digit right. So again the reverse process is for left shift here, you can see. Okay, so yeah, this is all about the theory, but let's look at the okay. So I have prepared one small program here, and then here I have written what I had already discussed. So here E is 5, and then B is 3, and then we have E bitwise AND E ampersand B. Similarly, we have bitwise OR and then bitwise XOR. So yes, and then this is the output, like E and P, E over P, and E XOR P. Okay, we'll see here. You can see even 1, 7, and then 6 are there for this operators output. And similarly, we have the bitwise not, that is what we have already explained to you. And then yeah, so let's run and then see the result. Yes, now here is the result, right? So you can match it like 176, and then we have -6 here for not, and then yeah, and then we have the left shift. So that becomes actually 5 left shift 1 becomes 10, and 20 right shift becomes 5. So yeah, that's it for today, and have a great day. Let's meet on the next video. Thank you.